again. So titration was, remember that you had 4 reactions, right, for salt preparation. We were talking about salt preparation. I told you that there were three, four reactions, right? Which could be used for salt preparations. You got a metal plus acid reaction. You had base plus acid reaction that would also produce a salt plus water molecule. You've got a carbonate plus acid reaction, salt, water, and carbon dioxide. You've got an ammonia plus acid reaction, which would give you an ammonium salt. So you had all these reactions that involved salt preparation. And the first method of preparation was excess method, where you had an insoluble reactant. So no matter what the reaction is, as long as you have an insoluble reactant, but you got a soluble salt, that is going to be excess method. That method was easy. What you would do is that you took a piece of magnesium, you added it to sulfuric acid, you kept on adding Mg, more of it, until every last molecule of H2SO4 is gone, and your solution only contains one thing, which is MgSO4. That's about it. So the aim is to get rid of all the acid. I mean, Mg itna zyada add karo, you keep on adding Mg so that all the H2SO4 is completely gone. And once that is gone, uh, the solution would only contain MgSO4. The excess Mg can simply be removed by just picking it up or by just filtering it if it's in small pieces. So you just filter it out, and your solution would only contain a salt. That's it. So then you've got, so we did a lot of excess method, and then we started doing titration, which was that titration was that you had one second. So titration was you got a soluble reactant and the products are also soluble. So that means whatever reaction that you do, I mean the 4 reactions that we studied, if the reactants are all soluble and the salt is also soluble, then you can't use excess method, because if you add something in excess, you can't really pick it out. So if you have NaOH and HCl, you've got 2 colorless solutions, liquids, and you're trying to mix them up. Now you have no idea. By looking at it, you can't see the particles. Like by looking at water, you can't really. By looking at a teacup, you can't really figure out how much sugar is added to it. So by just looking at a flask or a beaker that contains HCl, you can't really tell how much particles of HCl does it have or how much NaOH it has. And if you mix them together, maybe you might add too much NaOH or you might add too much HCl. But if you've added, I mean, they're going to form salt and water, but if you added excess of HCl, you can't remove that. If you have added excess of NaOH, you can't take it out, because now it's soluble. It's like mixing Coke and orange juice. Like if you mix them together, you can't really take out or separate the Coke from the orange juice. I mean, that's kind of impossible now. So it's impossible to separate two soluble things. So the purpose of titration was that you have to ensure that the salt that is produced is not contaminated by any extra HCl that you've added or any leftover NaOH. So you have to ensure that if you're adding 10 particles of NaOH, then from the other side there should be exactly 10 particles of HCl added. They should not be added in excess. I mean, it would be wrong if you added 15 particles of HCl, because then 5 particles would contaminate the salt that you have. Okay, so for that purpose, you did titration. And the way titration worked was, the way titration would work was that NaOH was added from the top, HCl was at the bottom. Now, since it is hydrochloric acid, it is acidic. Slowly, drop by drop, you would keep on adding NaOH. And every particle of NaOH would react with HCl to form NaCl and H2O. So there would come a point when the last molecule of HCl in this flask would react. And that is the point when you should stop the NaOH from adding further NaOH. Because if you start adding, that's the point when you should stop. If you don't stop, there's extra NaOH going in because all the HCl is already gone. It's completely gone, and you've started adding extra NaOH. That would make it basic, because NaOH is a base. So you've got indicators that kind of tell you what's happening by color changes. Methyl orange was one. We did methyl orange that it would turn from red to. I mean, in acid it's red, and all of a sudden when you just add one extra drop of NaOH, it would turn yellow. And then you had another one. Hopefully this image uploads just a second. So you had another one which was phenolphthalein, and that would turn from colorless to pink. No idea where the image went. So hopefully it's going to come back. It's going to turn from colorless to pink. So is this all clear? The purpose of titration.
Yes, sir.
Baki Hamza, is this clear?
Yes, sir.
So we're gonna write the explanation. How would you state? One second, let me.
Sir, can you show the diagram again?
Each second. I mean this diagram.
Yes, sir.
Chalo.
Okay, done, sir.
I'm also sharing the board link. If I have it, I have. इधर ही शेयर कर रहा हूँ इसमें चार्ट में.
Sir, what's the XX inside the beaker? Inside the flask?
1 second. Nee, that's just showing that every time you got 10 particles of HCl, so you start adding NaOH from the top, and every time HCl reacts and it's gone, it turns into NaCl. Okay, so slowly all the HCl gets used up, and when the last molecule of HCl in the flask goes away, that's the point when you should stop, because if you don't stop, then you're adding extra NaOH from the top, so that would make it basic. I said, let me quickly do this beaker thing. It's as the color changes of phenolphthalein, that's so phenolphthalein is going to have these colors. I mean, the beaker would change color. So we're going to write the description now, and we're going to write the description of what we just did. So basically, this is what you're going to write in your exam, because you're not going to draw. I mean, most of the time you wouldn't be drawing diagrams. You'll be explaining this. So you've got the question is, I mean, let's say the exam question is make. As the question is, you're supposed to make pure dry crystals of NaCl. So make pure dry crystals of NaCl. That's the question. So what you're going to do is, first thing you have to think of a reaction. So NaCl, the acid that you will use is HCl. And you can add a metal hydroxide to it, NaOH, a base. So it's going to produce NaCl plus H2O. Okay. All of them are soluble, so Na group 1 compounds are all soluble. Acids are all soluble. NaCl, that's group 1, that's also soluble, and you've got H2O, which is a liquid, right? So all of them are soluble. So the first thing is fill the burette with NaOH. I mean, that's the first instruction. So that's a first instruction. That's exactly what we did over here as well. I mean, it doesn't really matter. You put NaOH at the top and the HCl at the bottom, or you do it the other way around. It doesn't really matter. I mean, HCl could be added from the top and NaOH could be at the bottom. So, and then you fill the flask with HCl. Okay, that's the second step. So the second step is you take a pipette and you transfer. Now, pipette is like a transferring thing. It's like a, so you take a pipette, 25 cm cube of HCl into a conical flask. Okay, so you put it into a conical flask. Pipette is like a dropper. It's like a dropper that measures 25 cm cube. This is what a pipette is. It's like a syringe. I mean, the modern pipettes, I mean, hopefully everyone knows what a pipette is, but I'm going to show you anyways. So it's like a device that's used for transferring things. Modern pipettes are more like syringes, like this one. You pull this thing up, and it fills up with 25 cm cube, and then you release it somewhere else. The older ones were like this. The older ones were kind of like this. You had a suction device at the top, and it would fill it up. You would fill it up, and then you would release the liquid at some other point. So don't get confused that we're using pipette to transfer 25 cm cube HCl into a conical flask. So that's how we add or transfer liquids. Like if I want to put a liquid over here from a beaker, I'm going to use a pipette. Think of my pointer as a pipette. I'm going to dip the pipette into the HCl solution and transfer 25 cm cube into this conical flask. So that's this thing. Pipette 25 cm cube HCl into a conical flask, and after that, you add a few drops of indicator. So let's add methyl orange. Add a few drops of. You don't have to write the name of the indicator in your answer. So I'm just going to put the name in brackets. I mean, you'll be asked questions about it, about the indicators as well. So add a few drops of indicator. So we can use methyl orange, or we can use phenolphthalein as well. So once we've added a few drops of indicator, the next part is start titration. Start adding NaOH from the top. So you start titration, and you add NaOH drop by drop. So this part is start titration, and you start add NaOH drop by drop. Now, once you've done that, when are you going to stop? When the color changes. Stop titration immediately when the color changes. So as an example over here, as soon you're adding NaOH from the top, as soon as NaOH, there's one tiny extra drop of NaOH added, it's going to become basic, the color would change. It would change from, it was acidic first, all the acid has reacted, so it's no longer going to remain red. One extra drop of NaOH would make it yellow. So that's how the color would change. So stop titration when color changes, and we can write it from red to orange yellow. And you stop titration. Once that happens, the next thing is, now there's a problem now. You've stopped the titration, right? We didn't discuss the next part. So what do we have in this solution? We've got NaCl and H2O, right? So I've stopped it somewhere over here. I've tried not to add extra NaOH, right? Is this clear? Salim, is this clear? Amna?
Yes, sir.
Yes, sir.
So I've tried stopping the titration before I've added too much NaOH, right? I mean, I've kind of stopped at this point. So my solution only contains NaCl plus H2O, but this NaCl is contaminated by one thing. What is that one thing that should be removed?
The H2O.
That's easy because, I mean, let's assume that I've removed the H2O. I've just evaporated it and it's all gone, right? So I'm left with the NaCl, but it's still contaminated by something else. What's that? कोई भी बता दे, what's the thing that would be contaminating this salt? It's easy to get rid of the H2O, that's easy. The indicator itself is contaminating it. I mean, look at the solution, it's all yellow. It's because of the indicator, you've added indicator to it, right? Is this clear? Amna, is this clear?
Yes, sir.
So now what you have to do is you have to somehow get rid of the indicator. So what you do is, there are two ways of doing that. One is you add charcoal to get rid of the indicator. Now charcoal is like that. It's like burnt wood, or the coals that you get for your barbecue. That's charcoal. They have absorbent properties. So you add that, and the indicator gets. I mean, the color, the orange and the red color, methyl orange, would get absorbed by this. So add charcoal to remove indicator. So that's one thing that you can do. Another thing that you could do is, what was the purpose of titration? The purpose of titration was that you weren't able to actually figure out how many particles of HCl are being added and how many particles of NaOH were being added, right? So you wanted them to be added in exact amounts. But the problem was, by just looking at it, you can't really tell in the solution how many particles were present, right? But now, once titration is done, now you can actually exactly figure out how much NaOH reacts with how much HCl. Because previously you weren't able to figure out, like, should I add 2 cups of NaOH into it, or should I add 3? Because you didn't know how much NaOH was present in it, right? But once you've performed the titration, you're now exactly sure that you had a certain amount of HCl and you added a certain amount of NaOH into the mixture. So now you're kind of exactly sure how much needs to be added. So what you can do is, you can note down the volumes used. Right? Note down volumes used. And this time repeat without the indicator, because if you know that 25 cm cube of HCl in the flask reacts with 8.5 cm cube of NaOH, now you don't need to actually titrate it. It's because you know exactly what quantity mixes with what quantity. So you just note down the volumes used, and this time you are going to repeat. As this time you're going to repeat without indicator. Is this clear?
Yes, sir.
And the last thing is you get rid of water. That's crystallization. So that part is crystallization. One second, so that part is crystallization. I'm just going to write crystallization. It's so you have to explain what crystallization is. Evaporate the solution to saturation point. And once you've to saturation point, cool gradually, and once in saturation point, cool gradually to obtain crystals. And you filter those crystals and dry them in sunlight. एक second. Hey, what's the question? Acha. Hamza, note down volumes of these. Like, Hamza, what was the issue? Okay, when I was trying to mix, NaOH and HCl, right? I didn't know what quantity of NaOH would mix with what quantity of HCl. Hamza, is this point clear?
Yes, sir. Go ahead.
But now, once you've performed one titration and the color changes, you know exactly like
Yes, sir.
this much HCl reacts with this much NaOH, right? So now you know
Yes,
exactly.
sir.
So once you've noted down the volumes, like 25 cm3 of this reacts with, let's say, 8.5 cm3 of NaOH, right?
Yes, sir.
So you've seen the reaction happen. So now you exactly know. So why do the titration now? Like just take 8.5 cm3 and mix it with 25 cm3. Is this clear?
Yes, sir. Go ahead.
So that's, you just note down the volumes used and you repeat without indicator. Okay. अच्छा उसके बाद है कि there is so we're going to do some more questions similar to this titration. Remember, everything must be soluble. So let's try and make so let's try and figure out, can we make MgSO4 via titration? So first thing is, MgSO4 a soluble salt or not a soluble salt? Can anyone tell me what is MgSO4, soluble or insoluble?
It's soluble.
Okay, that one is soluble. Like if I look at the data booklet, just a second, let me. So this data sheet. So if we look at SO4, for SO4 it says that all sulfate salts are soluble except for these 2-3. So they are soluble. So this is soluble aqueous. What acid would I use?
H2SO4.
So we're going to use H2SO4, and I've got three options to make this salt. One is a metal, right? I could use a metal, which is Mg, or I could use a base, which is MgOH2, a hydroxide, metal hydroxide, or I could use a carbonate. Right, so I've got three options, and I'm just going to copy these three. Can I use titration for any one of them?
You can use titration for the second one.
Now remember, for titration, everything must be soluble. In the first one, what's the byproduct? What's the thing that's metal plus acid gives you H2, right? Base plus acid gives you water. And in this reaction, the last one, you're going to get water and carbon dioxide, right? So anyway, so check out the solubility. The first one is a solid. So which method would you use for that? I mean, Mg is a metal. So this one is soluble. Acids are all aqueous anyways. So soluble salt from insoluble reactant, that is excess method. MgOH2, does it even know what MgOH2 is? Soluble or insoluble? If you look at the sheet about metal oxides and hydroxides, I don't know if it's this one, the top one. So only group 1 hydroxides are soluble, and those lower down in group 2. It doesn't include Mg. Mg is not there. So that means this is not soluble. Only group 1 hydroxides and oxides, and the ones that are lower down in group 2. So this is also a solid. And carbonates are all insoluble as well. So over here, if you pick any of the three reactions, it's going to be excess method. Is this clear? You can't use titration for this one.
Yes, sir.
Yes, sir. It's clear.
TK, an excess method is you keep on adding Mg until all the sulfuric acid reacts and finishes and turns into MgSO4. So the solution would have no H2SO4 whatsoever. You're going to add Mg in a lot of excess. Keep adding Mg until no more H2 gas is seen because you run out of H2SO4. So the solution contains only the salt. It's not going to be contaminated by the acid, the leftover acid. There should be no leftover acid whatsoever. The extra Mg that you've added, you can just pick it up, filter it out, and you'll have a salt solution. That's it. So you can't use titration for this one. Let's try another one. Let's try. Let's try barium. What barium? Barium nitrate. Let's say I want to make this salt. Is this soluble or insoluble? What is NO3? Whenever
It's soluble.
so whenever something contains group 1, NO3 minus 1, or anything NH4 plus 1, they're all soluble. So this is aqueous. So it's a solution. It's going to be produced. What acid would you use to make this salt?
HNO3.
HNO3.
Because it's going to be HNO3, and I say you've got three options. You could use barium metal, right? Or you could use barium hydroxide. Let's try it with barium hydroxide. With hydroxide, it's going to form a water molecule, right? As anyways, barium, you could have used barium metal like the ones previously, but barium is obviously a metal, so that's not soluble, right? You could have used barium carbonate as well. Carbonates are all insoluble as well, so that's would not be titration. But barium hydroxide is soluble. Like if you look at the solubility of hydroxides, it clearly states that group 1 are soluble and those lower down in group 2. So it clearly states that barium hydroxide is soluble. So those lower down in group 2, so that is soluble. That is aqueous. So just 1 second. This one is acids are already aqueous. And this is going to be, so this is titration. This reaction over here, is this clear? This reaction is going to happen via titration. Clear?
Yes.
Yes, sir.
And what you're going to do is you're supposed to mix them in exact quantities because एक भी ज़्यादा डल गया ना तो you can't take it out of the solution, right? So you have to write the whole thing, titration. So tell me, send me the answer to this. Like you're supposed to make barium nitrate crystals. Everything is going to be exactly the same. I mean, it's going to be the same exact explanation, except the names would be different. You're going to add barium hydroxide from the top. I mean, you could choose whatever you're adding from the top. You could have switched them around. And you're going to add nitric acid. The beaker would contain, or the flask would contain nitric acid at the bottom. और फिर इनका reaction होगा, salt would be produced. So you'll add an indicator. As soon as the nitric acid gets used up, you should stop adding the base, because if 1 drop of base extra is added, the indicator would change color. So send me the explanation for this and try doing another one. Try making this salt, which is, try making K2SO4. I mean, think of the reaction yourselves. Try making K2SO4. I mean, this is a separate question. Try making K2SO4 by titration. For this, you would have to think. No, Hamza, it's flask में जो भी आप add करते हो, that is the one that is pipetted, right? So I told you, okay, it's I mean, you could have switched NaOH and HCl I mean, you could have switched them around. Hamza, is this clear?
Okay, sir.
But whatever is in the flask, that is transferred into the flask through a pipette, like a dropper. You have a beaker somewhere, उधर से ना उठा के इसमें डाल देते हो. अच्छा, so anyways, try doing these two questions. One of them is write the whole explanation for this. And for this, make the reaction, but make that reaction कि जिसके लिए titration use होगी. So make the equation and explain the titration method. Explain the whole method of preparation. Which is basically I'm talking about titration. So do these two questions and send me the answers. बल्कि अभी करो, you'll still have 10 minutes, ठीक है? So stay connected. Send me the first one. I'll just have a look then.